record. Excellent. Now, folks, there is an area of mathematics that we have been studying over the last few weeks. And that area of mathematics is not studied a lot in school. It's a very important area of mathematics. Do you remember it was called combinatorics? Oh, sorry. That's not exactly true.
Combinatorics.
Combinatorics. So combinatorics is the study of counting. And the area of combinatorics called partitioning is actually a strategy where you split numbers into different pieces. Let's look at some examples. If you took the number 45 plus 33, wouldn't they have told you in school to separate 45 to 40 plus 5, 33 to 30 plus 3, and then add 40 plus 30 is? You can say it out loud.
70.
70.
And 5 plus 3 is?
8.
And 78.
78.
You can do it with 3-digit numbers, and you can do it with subtraction. You can do a lot of different things. What we're going to be studying is partitioning numbers like the number 3. So let's look at partitioning the number 3. I'm going to show you how to do the first one, and you're going to do the next one. So everybody, please write out partitioning the number 3. And when we do that, we always start out with the highest number. We always start out with the highest number. And in this case, the highest number is 3. So 3 is the first partition where we just use the whole number. Now, the next partition is with the next largest number. What's the next largest number we can use? Go ahead and say it. Go ahead and say it. You'll have to unmute yourself.
2.
2 plus what?
1.
Exactly. But remember, 1 plus 2 is the same thing, and that's just a different permutation. For partitioning, we just say 2 plus 1. And who wants to tell me the final one? The final one. Gabby?
3, 0.
This is really, in a way, already 3 plus 0. So we would not add 0. William?
1.5 plus 1.5.
You know, William, I love it. Everybody, 1.5, 1.5 plus 1.5 equals 3, yes? What about 2.75 plus 0.25? What about 2 7/8 plus 1/8? Guys, aren't there an infinite number of ways to make 3? But when we talk about partitioning, we are only talking about whole numbers. Who knows what a whole number is? Whole numbers. Who can give me the sequence of whole numbers? Kelsey?
There is a number that doesn't have halves or something. It would just be like just 3 instead of 3.5 or 2.5.
I love it. I think that's a great explanation. And do you, Mark, have a better or different explanation?
I
I think that it's just a whole number that it doesn't show halves, quarters.
Yeah,
Something
I
else.
think that's pretty much, I think I would go like this. I think that's pretty much what Kelsey said. But can somebody give me the actual numbers? Like you could write out something or say penny.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Watch what we do, penny. Because we know it goes on till infinity. We put a few dots and then we close the bracket. Now, is there a number missing from this group? Does anybody see a number missing? I'm going to go with Sarah on this.
0.
Ah, everybody write that down. Everybody write that down. The numbers that Penny gave us, which is just 1, 2, 3, 4, ... Those are actually called natural numbers. Those are called natural numbers. And then we have another sequence of numbers called integers. Who knows what an integer is? Gabby?
Something like a half or a quarter. Any number that's split into pieces.
Well, that is not integers. Integers, in a way, are like whole numbers like 0, 1, 2, 3, ...
Oh, I know.
But they also include, go for it.
Negative numbers.
So the opposite of 1, the opposite of 2, the opposite of 3, ... all the way to negative infinity. Now, we're not going to be using negative integers today. We're going to just be using really the counting numbers, really just the counting numbers. So, Sunya and William, I really liked what you did, but I'm going to ask now that somebody give me, Isabella, can you give me the last partition for the number 3? What do you think, Isabella? Anybody have any ideas? Olivia? Hayden, what about you? How about you, William? Oh, sorry, Hayden, go ahead.
1 + 1 + 1.
Of course, everyone, 1 + 1 + 1. Now, I want you all to learn partition notation. Can you guys say that? Partition
notation.
Partition notation.
and partition notation. And this is how mathematicians do this. For the number 3, they would write parenthesis 3 close parenthesis. Pretty simple. For the next one, 2 and 1, they would write 2, 1. But for the next one, are you ready for this? I think you're going to like this one. 3 is actually called a superscript. Everybody say that out loud.
Superscript.
Superscript. So we know that right now, we know that the number 3 has how many partitions?
3.
3 partitions. Now what I'd like you to do is I'm going to let you look at the page we just created, and I'm going to ask you to give me the partitions for the number 4. And I'm going to ask you to give them to me in partition notation language. So go ahead. Everybody write it down. Everybody write it down.
Mr. Kramer, I'm sorry, but my dad forgot to print my pages. I'm so
Buddy,
sorry.
you do not need to print the pages. In fact, today it is even less important. Just write out partitions for 4. And in the future, Bayram, just so you know, it is your responsibility to get them printed out. So don't put it on a parent. You should, it's you. And by the way, I also take responsibility because I sent the documents over late. That was my fault.
Okay.
All right. I want you guys to try to finish up. And all right. So who wants to give me the first 2 partitions? Sunyi, and Sunyi, I cannot see you. I can only see your hand. I cannot see your head. Now I still can't see your mouth. Come on, angle that computer down or stand up or something. But angle that computer down is so easy because then it'll put you in the middle of the screen. Beautiful job. Go Sunyi, but unmute yourself. Everybody unmute. Come on.
4.
Wait, you got to say parenthesis 4.
Parenthesis 4. Parenthesis 1, comma 3.
Remember, in order. In order. Come on, Sunyi.
What do you mean in order?
It would be 3, 1. Do you see how when we did partitioning for 3, it was 2, 1. We didn't go 1, 2. If you go in order, you'll make less mistakes. Okay, let's go now with Sarah. Go. We're going to go for 2, Sarah.
2, comma 2.
2, 2. Give me one more. Oh, wait a minute. That's a repeat. So what do we want to do for that?
Oh, 2, and then you do like a smaller 2.
Right. And you can actually just say 2, 2. For
2,
that,
2.
you could just say 2, 2.
And then 1, 4.
Well, wait, you always start with the number.
Oh,
You always start with the number 2. And William, can you help out?
2, comma 1, comma 1.
No, we don't do 1, 1. When we have 2 1s, what do we do, Mark?
Right. It's smaller 2.
Where? Right here?
No, on the upper.
No. There are 2 2s in this one also?
you have to do comma 1, and then you do the little 2.
Nice, Sarah. That's exactly right.
Wait, the little
exactly right. Who's got the next one? Let's go with Kelsey.
So 1, 1, 1, and 1.
I am going to agree with that, but I want it in superscript notation.
You 1 with a small 4.
Oh, you can say 1, 4.
I
You
was
can say
also
one-
wondering, could
Yes.
you do a negative 1 and a 5?
Remember we said when we went over the different types of numbers, we said we're not doing integers today. We are just doing natural numbers.
Okay.
But that is a great, not a good question, a great question. So now let me ask you this. How many partitions did we get for the number 4? Say it out loud.
5.
5.
5.
Now, I
5.
want you to watch what I'm going to do here. What I'm going to do here is I'm going to make a little chart. I want you guys to make this chart as well. Write down a little number, like a hashtag, and then write partitions. Now, leave yourself a little space, and let's write down the numbers 3, 4, 5, 6, and the number of partitions for the number of 3 were what? Does anybody remember?
3.
It was
3.
3. How many partitions for the number 4?
4. I mean 5.
5.
Now, do not say it out loud. Write down your conjecture. Conjecture means educated guess as to what you think the number of partitions will be for the number 5. Please write that down. And then I want to hear from some people, but do not cross out your answer. I want to hear from William. Go. Number.
6.
You think it is 6. And what about you, Mark?
I said
7. What about you, Hayden?
7. I said 7.
Penny?
I think it's 7.
7? All right. Well, you know what? Let's do it.
Yes.
So what I want to see you guys do right now is write partition for 5. And I want you to find all 7 solutions using our partition notation, starting with 5. But I'm really looking for the notation to be very, very clean. Very, very clean. Because that's what mathematicians do. They really know how to write clean lists of numbers.
I want you
Well, 5. No.
I'm going to give you just a few minutes, and maybe I should let you look at your partitions
4 plus 1.
for number 4.
Put the parentheses.
Sometimes that can be helpful.
Um, 2, column 3.
Oh, wait. You have to have 1 plus 1. How you would do it superscript, right?
How can you do this? Because we have odd numbers and this.
Mr. Kramer,
Yes.
so we're not going to, like, if 3, 1 stands for 1, 3, 2. So like when I'm down at the other side like that I don't do that again. Like I don't do things 2 times.
Right. That's
Just a
exactly.
big switch.
That's exactly because that would be a
Okay.
different, Sarah. That would be a different permutation, right? Because if let's say for 4,
Yeah.
for 4 you had 3, 1, you wouldn't also do 1, 3, right?
Okay.
It
So
would
just it's you just know like it's also possible.
right, and that other possibility is a different permutation. Oh, Penny, that's cool. Penny, how many did you get?
7.
Cool, cool. So Penny, do you want to just read all 7 to me like lightning fast?
Okay. 5, 4, and 1,
Well,
3,
let's
and
say 4, comma 1, right?
4, 3, comma 2, 3, comma 1, 2.
Ah, you guys saw that little superscript, right?
2, 2, 1, comma 1.
All right. William, you want to take over there? And
2,
look at
comma 1,
I
2,
don't agree.
comma.
Hold on a second. Why don't we go with Gabby? And
I've got one. I have 2, comma 1, 3.
2, comma 1, 3. That is true, but it's not the next one. Kelsey?
Oh,
And actually, William may want to change what he had said before. William?
I think it's 2, comma 1, and there's a small 3.
Yeah, that's what Gabby said, and I agree with her. Jonah, if you show your face, I will call on you, but I need to be able to see you. Okay, Jonah.
Oh, I was about to say what Willie
All
knew.
right. Baron, what about you? I haven't heard from you today.
I don't really get the order.
Okay. So ask a good question. How about you, Sarah?
Is it possible it could be 2, 2, comma 1?
Absolutely. Everybody look at that. Literally, everybody look at that. 2, 2, comma 1, because it's 2 plus 2 plus 1. Remember, we don't go, we keep the highest numbers we can, and that's what combinatorics does for us. Okay. Now, Gabby.
Then you have 2, comma 1, 3.
Yeah.
And
Keep going.
And then the next one is 1, comma 5. 1, 5.
It's just 1, 5. Beautiful job. Wait a minute. Were you guys right? Were there how many partitions?
6.
No.
7.
No,
There
7.
are 7. So you guys were unbelievably on, and your conjecture was right. So isn't it obvious to you what the next one's going to be? Say it out loud. Go.
9.
9.
Of course. Of course. So
9.
what I want you to do right now is I want you to go for partition 6, and I have a pleasant surprise for you. William, why don't you wait till everybody has a chance to do it?
I have a question.
Yes.
All of the numbers all have a odd number.
So I kind of like that. You guys saw a sequence of odd numbers, which is kind of cool. And thank you, William, for pointing that out. Now, let's see what you guys do with it. So begin the process now. I hope you find all 9. So, Baron, did you understand the order on the last one?
Yeah, this time I understood the order. Sorry.
Okay, great. Because I think that you can see that 2, comma 1 gave everybody problems. And Sarah set us straight, but that wasn't easy. That one's a little bit harder. So thank you, Sarah, and thank you for sharing, Bayram, on that. That's really important. Okay, this time we're gonna start with Bayram, and then I'm just gonna call on you, and you have to give me the next one. And remember, order really matters. So Bayram, go.
5 and 1.
We say 5.
5 comma 1.
Good, good, good. And go, Sarah.
4 comma 2.
And go, Kelsey.
3, 2.
We don't need 3 yet.
Oh. Oh. 2, 2, comma 1, 2.
No, we don't need 2 either. So keep thinking about that. Mark, what do you, or Tess, I'm sorry. What do you think, Tess?
4, 1, 1.
But we don't say 1, 1. What do we do, Tess?
Mama.
We do 4 comma 1, but what do we write? We write a superscript of what, Tess? Oh, you are muted. You are muted. So how many 1s, Tess? How many 1s?
2.
There are 2. So we do 4 comma 1, 2. 4 comma 1, 2. Excellent. Mark. Come on, what did you write down, buddy?
Well, I didn't finish it.
I don't want you to finish it. I want you to tell me the next one.
3 comma 1, 3.
No, that's too many. Too many. Let's go with Jonah.
Oh, it's 3, comma.
Kenny, can you help out?
B2.
Everybody, it's 3, 2. Mark, do you see it? Do you see it? Jonah, do you see it? There are 2 3s. Now, I'm going to continue with William. Wilmore.
3, comma 2, comma 1.
Oh, that was sweet. That was a sweet one. I like that one. And Isabella, can you do the next? This next one's kind of interesting.
One's
What's the first number, Isabella? Isabella, is your sound on? Can you hear me? Can you give me a thumbs up if you can hear me? Because I can't see you. You're behind your name right now. Your mouth is behind your name. So what's the first number, Isabella? Olivia, do you want to help out? And I think you've got your sound off too. because I think you're trying to talk, but there's no sound on the computer. Hayden.
I didn't get to that one.
Okay, how about you, William?
I'm writing a list.
Okay, what about you, Gabby?
Does it start with a 3?
Of course, it starts with a 3 because we're not done partitioning this too. We've got to partition this too. So, Gabby, what do you think?
3, 1, 3.
3, 1, 3, everybody. There are 3 ones and a 3. Beautiful, beautiful job. Sun Yi, can you give me the next one? All right, go ahead, Sun Yi.
3, 1, 1, 2, 1.
Well, isn't the 3, 1, 3, isn't that already the 3 plus 1 plus 1 plus 1? And you would never put 1, you would never put 3, 1, 2, and then a comma 1. If there are 3 ones, you just have a superscript of 3. So let's start again with Bayram.
So now, how many ones?
Tess,
We
you wanna help
have-
out?
There is the
Go
first
ahead,
number.
Bayram.
Is the first number 2?
Yeah, we have to go with 2. Once you've
Yeah.
exhausted everything with 3, you must move to 2.
Mm-hmm. And then it's 2, comma, 2, comma, can we?
And let's help
I'm
out.
not sure what the second one is. It may
Okay,
be
go ahead, William.
2, comma,
It's
1, 4.
2, 1, and 4.
Yeah, that's what I was gonna say, but I
Uh,
wasn't sure.
No, I do not agree. And let's see what Hayden has to say.
I think I know.
Hayden?
Is it 3, 3, 1?
Well, you would never write 3, 3, 1. You would write 3, 2, 1 if your number was 7. But this number is 6.
Wait, can I take a guess again?
Hold on, let's go with Penny.
2.
It's 2, 3, everybody. 2 plus 2 plus 2. There are 3 2s. Penny, that was beautiful work. Tess, do you have the next one? This is where it gets a little challenging, guys. And I really love this challenge. Okay, Tess, you gonna try the next one?
2, 2, 2.
I couldn't hear you.
2, small 2.
Oh, you mean you wouldn't do a 2, 2, you do a 2 superscript 2. Is that what you meant to say 2, 2?
Yeah.
Okay, good. And then?
And 1, 1. 1, 3.
No, you remember we'd never say 1, 1. Remember? That was the one you did before. If you want 2 ones, you have to say comma.
1, 2.
Right, comma 1, 2. Yes, Tess. Beautiful job. Kelsey.
2, 1, 4.
2, 1, 4 is right. And everybody give me the last one on 3. 1, 2, 3.
1,6.
No,
One comma.
no comma, no.
1,6.
It's just 1/6. And guys, were we right?
No.
No.
What do you mean no? What do you mean no?
It's not.
Yeah, it's 9.
How many?
Supposed to be 9.
How many are there?
7.
11.
Oh, whoa. Hold on a minute. Who can tell me what pattern is forming here? Who can tell me what pattern is forming here? 3, 5, 7, 11. Hold on a second. Before we go explore that, how many partitions are there for the number 2?
2.
It's 2 and,
1, 1.
excuse me,
1, 1.
1 little.
2.
1, 2. We
Mr.
say
Kramer, that
1,
just
2.
says partition.
Partition. So there are 2 partitions for the number 2. So guess what, guys? Isn't this a sequence of numbers you know? What is that sequence of numbers? I'm going to go with somebody who I know loves these numbers. These are some of my favorite numbers in the whole wide world. And I mean favorite. Mark,
5.
guys, these are the prime numbers. Everybody go like this. Make that little bracket and write the prime. They're all prime numbers. Numbers are only divisible by 1 and the number itself. So everybody tell me what 2 is. 1
One.
times 2. Everybody tell me what 3 is.
1 times
1
3.
times 3. Everybody tell me what 5 is.
1 times 5.
Everybody tell me what 7 is.
1 times 7.
Times 7.
Everybody tell me what 11 is.
9 times 9.
Now, what do you think? What is your conjecture about the number of partitions for the number 7? Come on. I mean, look at these prime numbers: 2, 3, 5, 7, 11. They didn't skip any. Jonah? If anybody next knows the next prime number, please raise your hand. I'm going to go
13.
with Isabella. Are you raising your hand, honey? I can't see. It's like out of the picture. No. How about you, William?
13.
Does anybody agree with that? Does
No.
anybody agree? And what would the next prime number after 13 be, guys?
15.
No. 15 is a multiple of 3.
Uh-oh.
3.
15, everybody, is
It's a multiple of
Aaron
3.
said 3 times 5. So 15 is not prime.
However, 17 is.
17.
Guess what? 17. So maybe for the number 8, it's 17. What about for the number 9?
21.
21.
Uh-oh. 21 is 3 times 7.
No, 3 times 7 is 21. Yeah.
Yep. Come on, what's the next prime number? Who's got it?
23.
Oh, guess what, guys?
Whatever.
23 would be my conjecture for the number 10.
9.
But for the number 9, what's my?
19.
19.
Oh, 19. All right, guys. Everybody now, please partition the number 7. In perfect notation, your job is to find all 13 unless it's not 13. Go. Oh, and Jack, since you joined us late, I'm going to explain to you what we're doing. The partitions for 7 are 7, and then 6 plus 1, and then 5 plus 2, and then 5 plus 1 plus 1. Do you see how we don't do 5 plus 2 and 2 plus 5, Jack? We don't do the permutations. And then we go in order, but there's special notation that I taught everybody, Jack, which was just a 7, 6 comma 1, 5 comma 2, but this one is special, Jack. You ready? You put a 5, then a 1, but you see how there are 2 of them, Jack? So you put a little superscript of 2. Okay? And so why don't you see if you can find and do them in that notation. That's called partition notation.
Copyright.
You suck, I can help you. 2.
Who would ever think that partitioning is such an interesting area of mathematics? But it is not easy.
Mrs. Creamer,
Yes.
I need some help.
Which one are you working on, buddy? Can you tell me where you are?
I counted mine and there were only 12. I think I'm missing one.
Well, for the next few here, what did you do for the 4s?
4. 5, 4 comma 3. Three.
Very nice.
4 comma 2 comma 1.
I like it.
4 comma 1 3.
Amazing. And so, Jack, do you see that 4 plus 3 1s? Right?
And 3 comma 2 comma 1.
I do not agree.
With 3 comma 2 comma 1 2.
Don't agree. So that's where you have to go back to the drawing board. So we found our place, William. Well, you are all working diligently. Jack, do you want to pick up a pencil? Since the only way to do this is to write numbers. If you just think about it, it's interesting, but that's not mathematics. It is not a thought exercise. It is an active connection with numbers. In fact, if you have a question, this will be a great time to ask that.
Mr. Kramer?
Go ahead, Jack.
Well, what about 3 comma 3?
Ah, well, you wouldn't say 3 comma 3. You would put a superscript of 2. So that's 2 3s. But what's left? Come on, 3 plus 3 plus.
The
To get 7, to get 7. 3 plus 3 plus? 1. Absolutely. So William, do you see that 3, 2, comma 1 is the next one? All right. And then who knows the next one? That's a really interesting one. I'm going to go with Gabby on this one and then Hayden.
I think the next one is 3, comma 1, 4.
I am going to say not
2,
yet,
2.
but that's a good
Comma 2,
one.
2.
Say again, honey.
3, comma 2, 2.
Ah, that's very close to the right notation. Hayden?
I was gonna say what Gabby said.
Okay. Anybody else have different notation for that one? Sarah?
2, comma.
Two things. First, I have 3, comma 2, and then you do a so you do 2, and then you do a small 2.
So
Super.
remember, you just say 3, comma 2, 2. So Gabby?
3,
and
comma
Hayden,
2, 2.
3, comma 2, 2.
And then I also
That's-
have, doesn't 3, comma 2, comma 1, 2?
Absolutely. That would be the next one. You want to keep going, Sarah?
I haven't written any more down, but I can. I
Okay.
think of.
How about
some
you,
more.
Tess? Do you have another one for me?
3, comma 1, 4.
Ooh, nice. So you see, Gabby, that was your 3, comma 1, 4. And beautiful, beautiful job. And Kelsey, go for the next one.
3, comma 2, 2.
3, comma, 3, comma 2, 2. I think we're out of 3s. I think we are out of 3. Who's got the next? And I'm going to go with Bayram on this one.
Sorry, I was already unmuted. And I thought I was muted. So 2, it's also the 2. 2. Two, 1. So that's like 3, 2, 1. Oh wait, no, I can't do that.
All right.
Can we do? Wait. I think I have an idea.
Okay.
2. Like what is it called again?
Just say 2.
2,
and
2.
I want to say
2, 2. Like the
yeah,
small 2.
2, 2.
So that's 4. And then 1, 3.
That is definitely one of them, but not the next one. Go, Jack.
4.
Well, no, 4. We've done all our 4s. We're done with our 4s. And how do we go with Wilmore?
2, 2, 1, 3. Comma.
I'm gonna go with there's something else here. William.
I was just thinking that we should start with a 2.
I totally agree. Tess, do you have our notation?
2, 1, 4.
2, 1. What do you mean 2, 1? You would always go in order. We've already done 4, 2, 1. So that would be a repeat. Come on, guys. Gabby, go.
Maybe 2, 1, 5, but that might not work because we have 5, 1, 2 already.
Actually, we don't have 5, 1, 2. Oh, I see what you're saying. You mean 5, 1, 2 here. That's right. So we don't want to repeat that one. Come on, guys. Nobody
I
has.
said 215, 215.
Yeah, but two, you would never say 2-1. It's just two if there's only one two. But come on, guys, we need to use multiple twos. William,
Two, two,
wait, no, I'm gonna go with Tess and then Hayden.
Two, 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 comma, 3.
I like it, but no, because we already have 2 2s and a 3. Hayden.
I think it's 2, then a small 3, then a 1.
Of course, everyone, it's got to be 2 plus 2 plus 2 and then plus 1. Absolutely. Now we go with 2 2 comma, come on.
1, 4.
No, not 1 4.
3,
1
3.
1, 3.
and then we go with, come on guys, everybody say it.
7, 1.
No,
No.
1, 7. 1, 7.
no,
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 we're still
no,
in the-
that is not the next one. Come on, guys.
1,
Olivia, do you know the next one?
2.
Olivia, you have to unmute your computer. Your computer is muted. You are speaking, but nothing is being heard. You are speaking, but nothing is being heard. You have to hit unmute on your computer. Maybe turn up the volume. Hit some buttons. Hit some buttons. Okay, who's got this, Tess?
1, 7.
1 7 is not the next one. Penny?
2, comma, 5.
Not 2 comma 5 because we already have 5 2 over here. But I do like the 2, Gabby.
2, 1, 2, comma, 1, 5.
Right, guys, you've got to partition the other 2. So it's 2 comma and 5 ones. And finally, everybody say it.
1, 7.
7.
And how many partitions do we have?
15.
15.
Oh my God. Guess what,
15.
guys? So our prime number conjecture.
Composite. It's a composite number.
Yeah. So our prime number conjecture happened to be wrong. Isn't it amazing that this was such a coincidence? So the number 7 has 15. Now, I'm going to tell you the next 3. Would you like to hear the next 3?
Yes.
All right. So the next 3 are 22, 30, and 42. And I would love to see you find all of the partitions for 8, 9, and 10. Now, just for fun, would you like to know how many partitions there are? Let me see if I can figure this out. Okay, you guys ready? The number 30, the number 30 has 5,604 partitions. I want to ask you a favor. Please, under no circumstances should you try the number 30, because it would take you years and cost millions of lives. So we want to make sure you do what is reasonable. And 8, 9, and 10 would be beautiful partitions to do. If you want to go beyond, you know that that would make me very, very happy. So I want you guys to say goodbye to all your friends and say, we are combinatoric mathematicians. Say it out loud.
We are combinatoric mathematicians.
Yes, you are. By the way, I won't see you for 2 weeks. I will miss you very, very much. I will miss you. Yes, I have to start working on, no, it's winter break. It's winter break. So
Hi,
that's what
Mr.
it is.
Bye.
Bye, guys.
Bye, Mr. Trainer. Bye. Where's the bye? Bye. Bye. Bye.